Hello everyone, today is day 23 of solving a LeetCode problem every day. Today I'm going to be solving remove nth node from end of the list. So given the head of a linked list, remove the nth node from the end of the list and return its head. So in this case, we have 1, 2, 3, 4, and 5. N is equal to 2, so we want to go backwards 2 from the end of the list. So 1, 2, so we're removing 4, and we end up with this list 1, 2, 3, and 5. For the second test case, we have just one node 1, and we want to remove n is equal to 1, so 1 from the back. So we just return an empty list. And then in this case, we have 1 and 2. We want to remove 1 from the end of the list. So we remove this 2, and we're left with the 1. So this is how I solved the problem. I initialized a length variable. And basically what this length variable is going to store the length of the linked list. So let's say we have this test case right here. So what basically happens is we set current to be the head, which is 1. And then while current, we increment length by 1. So this first iteration, length becomes 1, then current.next, length becomes 2, current.next, length becomes 3, current.next, 4, current.next, and finally, last iteration, we set length to be 5, and then current.next becomes none. So now we exit this while loop. So now we got the length. Length is equal to 5. Next, I calculated the index. And so what the index is basically the index of the element we're trying to remove. So in this case, we are trying to remove 2 from the back, so we're trying to remove the 4. So the index we're looking for is 0, 1, 2, 3. So if we subtract the length, which is 5, by n, which is 2, we get 3. So what this allows us to do is basically traverse through the linked list and get to the right position that we need to be in. But before that, I calculate the index. I create a previous pointer and a current pointer, and these are pretty much just right next to each other. So previous starts before 1, and current is just going to be the head. And then first I have this case. So if index is equal to 0, this means that we're removing the beginning of the list. So in that case, we can just return head.next. So we'd return a list that looks like this. So if the index is 0, we can automatically just return head.next. Next, I loop through the range of index, which is whatever index we're trying to remove, and I increment the previous and the current pointer. So the reason why I do this is because if you guys don't remember how to remove a node from a linked list, what you need to do is set the previous node's pointer. So if I'm trying to remove 4, I need to set the previous node pointer, which is 3, to 4.next. So basically, I'm removing this link right here, removing this link right here, and then just making a link from 3 to 5. Now, you don't need to actually remove this. You can just set the link from 3 to 5, and it's going to be gone from the list. But let's see. So we do that. We get in. So this basically gets us into position. So in this case, index is 3. So current just goes up by 3. So 1, 2, 3, and previous goes up by 3. So 1, 2, 3. So now, or 1, 2, 3. So now we have previous at 3 and current at 4. And then we have 2 cases right here. Now we either have the case where current can exist. So current is 4, and since current does exist, we just set previous.next to be current.next, which is 5, which just essentially removes this from the middle right here. Now the other possibility is we can get a test case like this. So let's say, I'm not sure if this is the one, but let's see. So the index we're trying to remove is, let's see, 1 and 2, so 1. So we're trying to remove this 2 here. I think what it is if n is equal to 2. Let me check if this is the, yeah, so if, no, because then that'd be, so yeah, I think 1 should be right. So let's see. So index is gonna be n minus 1, or not, length minus 1, which is 1. So we're trying to remove the element at index 1. So then for I in the range of 1, we have, oh sorry, this second test case was not previous. But anyways, so if it's not previous, okay, I messed up again. I don't think this is even needed here. Yeah, okay. I just thought that through for a second, and there was no reason for that to even be there. Ignore that. I think I had that in there because when I was first writing the code, I would reach a situation where the index is 0, and in that case, previous would be null. But in this case, I just added this case here, so you don't really have to worry about that. You just want to set the previous node's next node to be the current node's dot next, and at the very end of this, you just want to return head. So yeah, sorry for making that a little confusing, but that's what it is. And then let's see. So time complexity is going to be linear. The reason why is we're just traversing n times at most. It's never going to be more than n times. And then second of all, space complexity. This is just going to be constant. And the reason why it's constant is because we're not using any extra space. So yeah, that's my solution for the day.